is. All right, James, let's label them out. What does the 12 then represent? Opposite, adjacent, hypotenuse.
Opposite.
Okay, and what does the x represent?
Hypotenuse.
Alrighty. So, as I keep throwing out to you, with trig, you got to know your three ratios. That mnemonic device is just one little bitty thing there. My encouragement to you as you start your homework, as we do our notes here today, is you maybe do a quiz or a test. I would throw a subject code out there. The more times you throw it out there, write it down, you're going to remember your trig ratios. So, what did we just say? You said sine, I think, or maybe you didn't. I don't know. I lost track. It is sine though. Okay. So sine of our angle, right? 26 degrees. And how do we write the next part? 12 over x. Opposite over hypotenuse. Now, the variable lands in one of three locations. We saw two of the locations yesterday. Numerator or denominator. We're going to see the third location today. So, it's in the denominator. And as we did a bunch of those yesterday, you saw the pattern happen. When the variable's in the denominator, you're going to set up in calculator ready form. You're going to solve for x. And when that happens, well, how's that going to be then in calculator ready form? Multiplication or division? It's going to be division. It's going to work out where x is always going to solve out such that it's going to be 12 divided by sine of 26. You can do the algebra and solve out for x by multiplying x on both sides. X's are going to cancel. And then you'll have x times the sine of 26, and then you're going to divide by sine of 26. Every single time that's going to happen. So as Eric said, it's going to be division. Go to that calculator, and before I start to using it for the day, I myself always just do a quick check mode. Oh crap, my calculator went back to radians. Yours probably doesn't do that every single time. Mine, being on the computer here, mine does flip back. So I got to make sure I'm in not radians but degrees. Mine will probably do that mine will do that every single day. Yours probably does not do that every single day. Okay, unless you probably had to change the batteries or something weird like that. So what do we have? 12 divided by what? The sine of 26. And again, default for side links is nearest 10. Okay. Okay, James? Okay. Anything else anybody's got? Which one? 12. All right. Interesting one. I like this one. What jumps out to you on number 12? It's a 30. And what have we been talking about with 30? 30, 60, 90. So on this 30, 60, 90, with this particular one, we do have another tool back here. On this one, we could actually come back around and do this by a 30, 60, 90. But this one can also be done with our trig, obviously, as well. Trig can do anything. 30, 60, 90 is only happening if it's obviously a 30, 60, 90. So in this instance, we could do this one. It's going to turn out to be the radical equivalent. Whatever the radical equivalent is, well, when we plug that into our calculator and we round it out, it's going to turn out to be 16.2. So let's think about this. Standing at the 30, one more time. Standing at the 30, what's the 14? Adjacent. So because this is talking about rounding it to nearest 10, I'm not going to necessarily worry about my special rights. I'm going to go straight to it. If it's a radical form, calculator can't do that. I got to use my 3060s. I got to use my special rights. X is my what? Okay, sine, cosine, tangent. What do we got? Yep, cosine of what? 30 equals adjacent over hypotenuse, and this is going right back to what we did in the last one, wasn't it? X is in the denominator, variables in the denominator. It's always going to turn out to be, knock on the door, division, right? So 14 divided by the cosine of 30. So cosine 30, we divide that and go to our calculator, and I believe that should hopefully be 16 point, what is it, 2? Okay. Now, if you did the cosine, if you did 30 by special rights. Okay? I'm not going to take the time to work it out here, but here's what's going to happen. That's across from the 60, right? This turns out to be the short leg of 14 root 3 over 3. We double that because that's representing the hypotenuse. So if I go to my calculator now, and I type in 28 root 3 over 3, I'm hoping to get 16.2. So those will be approximately the same. Not equivalent because they're definitely not the same, but they'll be approximately the same. 28 root 3 divided by 3, there's that same thing. Okay? So on that 30, I can go both ways. I'll get the same answer because I just demonstrated. Okay? But read the directions carefully. You've got to read them carefully. If it says simplest radical form, I've got to do my special rights. No way about it. But if the directions do say nearest tenth, I could do trig or I could do special rights, either one, and then I take that to my calculator. Okay. They both have pros and cons there. Good question off that. I like that one a lot. Anything else anybody's got? All right, let's talk about a new button today. Make sure your name's on the name on the calculator. Well, make sure your name is on the calculator as well, but make sure your name is also on the paper. All right. And that's the adjacent. What's the 24? Based off what you got labeled, sine, cosine, tangent. Yeah, we are changing nothing right now. Absolutely the same thing. Let's go write our equation. Cosine of the angle we're standing at. It's not 25, it's not 30, it's not 45. It's cosine of what? X. Yeah, my computer program I use to steal these pictures, use a question mark. You can write question mark, you can write X, I don't care. Just use X though. Cosine of X equals what over what? 21 over 24. Okay, cool. Now how do we get X by itself? Everything has an inverse, right? The inverse of addition is? Subtraction. The inverse of multiplication is? Division. The inverse of, pause, don't write this down. The inverse of a squared. Yeah, I mean, we've gone through this at the very beginning of the year, right? And we've used it all year, right? The inverse of a square is a square root. So everything has an inverse, right? Cosine has an inverse as well. So how do we show that? How do we get this into the calculatory form? How do we get X by, not that. How do we get X, come on. How do we get X by itself? So to get X by itself, we have to show the inverse of cosine. And in this instance, the way that we show that is this. It's very simple. Cosine to the negative 1. Inverse cosine of 21 over 24. The way to get X by itself is to say, hey, what is the inverse cosine of 21 over 24? Okay, that's going to be it. So when X is the angle, you want to do the inverse cosine. Now, we also call that, you'll see that more on Monday in your book. They're also referred to as the arc cosine. Arc sine, who cares? Inverse cosine, arc cosine means the same thing. Now, what we're going to do here is, good thing you guys lived at the time that you live, all right? Because it used to be the case that we had these huge pages. You'd have to go through, these big trig tables, all right? You'd have to go through and our calculator. All right, let's do this. New button on our calculator. It's not really a new button though. Look in your calculator. Where do you see that inverse cosine?
Oh, it's above the cosine.
Thank you, Spencer. Yeah, it's on the cosine button, but it has to hit second. So that's it. Second cosine. And now type in what? 21 over 21 over 24. That's it. That's the new thing for today. Hit enter. Okay, our default for angles in trig is usually to nearest full number, nearest degree, which is what? 29 degrees. We're done for the day. That's essentially it. Okay, so 29 degrees. Okay, now we're going to do some more. Just to make sure we're all good, but it doesn't get any more really crazy than that. Okay? Is that ticked?
What is your
Okay, so there we go. That's the one I'm looking for when we do our next quiz. Not Monday, but that's our next quiz. I'm looking for those three readings. You got your equation. Can you get in calculated form? Can you round properly? Let's go to the next one. Stand at the angle. Who cares? It's a variable now. We know how to deal with that. What do we got? 12 is. 16 is. Very nicely said. Sine, cosine, tangent. Sine. Thank you. Set it up. Sine of what? Equals. Alrighty. That's exactly what I want to hear. Alright. Calculator ready form. You got to know how to solve for x. We got 3 locations where it can land. Today it's the angle. So we say x is going to be inverse sine, not to be confused with, we could also say arc sine. Alright, either one is interchangeable. I like to say inverse sine, just how I've grown up. What's that, Yante? Don't worry about it. Nope, calculator takes care of it for you. Don't waste your time on it, okay? Alright, so then you just got to make sure that when you go hit second sine, that your calculator did register second sine, did hit the second button. Because if you don't, and you do type in sine divided by 12 over 16, it's going to give you a number. Now, let's use some kind of common sense. I mean, it's definitely possible you can get an angle that is that small. Probably not correct, but think that that probably doesn't make sense. So make sure your calculator is showing that you hit second sine, get that arc sine going. Nearest degree is what? 49 degrees. Okay. Let's roll. What do we got? We're going to jump around here in just a sec. 3. What do we got? Sine, cosine, tangent here.
Tangent.
Tangent. 22 is. 33 is. That's why we get tangent, right? Tangent of x is what over what? Again, if you didn't hear Leonte a second ago, he asked, do we need to reduce these? No, it doesn't matter. Your calculator can deal with it, so don't waste your time on it. Set it up. Arc tangent, second tangent, inverse tangent. But what I'm looking for then, your calculator ready form, as I keep demonstrating here. When you write a calculator form, show me that inverse tangent by tangent to -1 though. Don't write just tangent. Tangent to -1, that's the inverse. What is it? 22 over 33. Somebody get that rounded for me? 35? 34? 34? Sorry, I just couldn't hear. 34 degrees. Okay. All right, let's drop it. Let's go to number 6. Number 6. All right, go. Let me put a minute on my clock. Go do it for me. I think it's picture, isn't it? Or is it not picture? Ish, somewhat, ish. Right triangle has leg 1.5 and a hypotenuse of 4. Sketch it out. Find me those angles. No, we know one angle. Stop that deep side. Now, we don't know what the we don't necessarily know what the other leg is. Who cares? One leg is 1.5. Put it on there. But what else do we know? Hypotenuse is 4. Okay, what I'm just trying to get to you guys is be consistent as you work through things. Okay? Commit to one of those angles. Put your 1.5 up there. And however you just drew yours out, it's going to be maybe different than how I drew mine out, how Steph drew his out, how the Bay drew his out, or hers out, Ashley drew his out, my bad. Alright? But whatever. However you guys draw yours out, just be consistent in how you find yours out individually. And then together at the very end, your 2 angles will all be the same. So you do your math correctly. Okay? So as you find those 2 angles, X, Y, A, B, Bob, Steve, whatever you name them, All right. Names of Chloe and Sydney, Faye. I don't care. Okay. Get an angle name that'd be Sydney. It's pretty nice. Okay. So just be consistent. I'm going to use cosine for my first one there. Now, if you did sine first, you did cosine first, I don't know, don't care. I really don't care. You can tell. Somebody find one of those angles to be 68. And then you can go do trig for the other one. Or we could do what? Subtract 90 minus 68, right?
Yep.
90 minus 68 gives you what? 22. Enter, I think. Yes. 22 degrees for the other one. Okay? So they should be again complements of one another. What did we just say? 68 and 22 was it? Those are my two angles. All right, let's keep working here. Let's do a few more. Let's take over to the side, number 9. We did number 9 already. Only difference with number 9 is when I started this off with you, those are all 45s. Now we have something besides 45s. We said this was tied for slope. Who cares what the y-intercept is? Y-intercept in this instance is -4. Play that slope game, build off that -4. What's my direction say here for 2/3? 2/3 means what? What does up 2 over 3 mean?
Up to the right.
I know I'm being picky. I know. You know me by now, Eva. 1, 2, 1, 2, 3. Thank you. Up 2, right 3, up 2, right 3, as many times as we can. Up 2, right 3, and up 2, right 3 means what? Reversed. Thank you. Take that ID and make that line. Now we've already done this problem before. Again, we made a whole bunch of 45-degree angles, right? Or 45-degree triangles, 45s. A whole bunch of similar ones by AA similarity. Now we can do the same thing, similar thing here, but to make this acute angle, we're talking about the horizontal. And I'm going to highlight off of the y-intercept. Okay. And I'm going to go find in there myself a nice, find myself a nice right triangle up there. I'm going to use that slope all over again. Use that slope, use that 2/3. I've got a couple of options. I've got a right triangle here. I've got another right triangle if I want to do it right there, based off that slope we just did, right? These are all similar triangles by 2/3 plus it. Sorry, not by 2/3, by AA similarity. But I'm going to go with that 2/3, make my life easy. I'm trying to find that angle. We've just been doing this. We can find that angle now. Before, I can only give you 45s. That's the only thing we knew. We had 1, 1. We had 3, 3. We had 4, 4. We had 5, 5. Because those we knew how to do. Those were 45s. Slope was always 1 to 1. But now we can set up what? Sine, cosine, or tangent. We got tangent going, don't we? What is that? 2 over 3. And the thing you should realize is it's going to be tangent each time. Because with that tangent each time, that's that vertical, that's that horizontal. That's that vertical leg, that's that horizontal leg. So tangent of x. So inverse tangent, arctangent. And 2/3. So what do we got? Somebody second tangent, arctangent, 2/3. Nearest degree, what is that angle? 34 degrees. Okay. So now we can do special rights there, or we can do trig. What did we just say, 34?
Yeah.
All right. All right, let's go to the next one here. I like number 10 a lot. Number 10 is an SAT problem. Okay, we talked about this yesterday. Tangent ratio is 1. Put your calculators to the side, they're useless. write me that triangle. This one is great. I like this one, and it's absolutely going to run into a lot of classes next year with algebra 2, pre-calculus, and absolutely SAT. The tangent ratio is 1. What's that triangle got to look like? Alright, yesterday you guys threw a little bit of a kerfuffle because where I put my angle at. Where are you putting your angle at? Top or bottom? I'm sorry? Where'd you put your angle at? The top angle, the bottom angle? Or are you just waiting on me? Because wherever you're going to put it, I'm going to do the opposite, right? Uh-huh. You're going to put it at the bottom? Okay, I'm going to go at the bottom. Oh!
Really?
Really? I do get a little enjoyment out of this place. Alright. Who cares? Remember, who cares? Does it matter? No. Thank you. Alright, what do we got? Tangent ratio is what?
1.
It's 1, which means total. What does it mean?
Oh, it's the
Okay. Opposite over adjacent, right? So the tangent ratio is 1. Throw that in there. What does that opposite mean? What's that adjacent mean? What's my two sides? They're equivalent. So what is my actual length? 1 and
1.
yeah.
Oh, good. Okay, I feel better.
All right. So what we have going here is, as Yante just pointed out, and Jillian was going on there with it too, we have a 45 here hiding in plain sight. Okay, with that tangent ratio turning out to be 1, what we have then is a 45 then. Okay, it was not obvious to start off with, but with that tangent ratio being 1, it turns out we do have a 45, 45, 90. Cool. We now know immediately what the hypotenuse is. Hypotenuse is what? I'm sorry? Root 2, I think I heard. I better hear that.
Yeah.
Don't just say 2. 2 does not work that. You're thinking of a, what, 30, 60, 90. 1, 1, 1 root 2. All right, let's finish it off. Cosine ratio. Cosine ratio is what? Adjacent over hypotenuse, which in this case is 1 over root 2. Sine ratio is 1 over root 2. These answers are great. I will give you half credit. Why am I giving you half credit? Thank you. You guys realized that a couple days ago. And as you roll into, again, algebra 2 and physics and pre-calculus, those are not sufficient. Rationalize them. Now, you rationalize these enough, you're going to realize what the final result is. These are going to rationalize into root 2 over 2.
Mm-hmm.
And hopefully you also realize it happens to the first one. It's going to be the same for the second one, isn't it?
Mm-hmm.
So the first one is root 2 over 2. And the second one is, you're going to see that pattern. Root 2 over 2, root 2 over 2, and tangent 1. It's going to get burned into your head. Not this year, probably, but algebra 2 it will. Okay? I'm laying the groundwork for you now. But we used our trig right here, and Yante then pointed out that we had ourselves what? 45s. That's our kind of merging of these two then happening. Okay, backside we go. Go with the last one here. Sine of a half. Draw me that triangle. Sine. Sine of a half. Sine, sine, sine. Let's go with the bottom then. Yeah, Yante. Okay. Okay. I'm going to go with the bottom one. All right, I'm going to watch my time here, so we'll just kind of work this one together. Sine of a half, I'm just going to go with the bottom. Sine, sine, sine. What's the sine ratio? And I'm going to the bottom angle. So here's what we got, right? 1 here, right? And the hypotenuse you said is 2. What's that easy?
Yeah,
that's what else. Okay, so here's the thing. I know some of you are a little bit more comfortable than others, but there is definitely a pattern happening on this one. What do we got?
90, 60.
Right, we got the 30, 60, 90 pattern. Okay? When we have a leg and a hypotenuse happening in a relationship of a 1 and a 2 hypotenuse, that's a 36 to 90. Now, where does each one go? You got to make sure you're paying attention. If the leg is 1 and the hypotenuse is 2, what is that 1 then? That 1's got to be the what? Yeah, it's got to be the short leg, right? And that's the 60 is going to be across to make this then considered to be the long leg, which is the adjacent leg. So we've got everything. You better be quickly to tell me what is length of a long leg. 1 root 3. 1 root 3. Okay. Now we can wrap our ratios. Now you can do Pythagorean theorem. Like if you're not thinking like that, Pythagorean theorem is always my backup. We can do Pythagorean theorem. Can't do trig there because trig's not going to give you a nice number. All right, finish it off. Cosine, cosine. Cosine ratio is root 3 over 2. Tangent ratio is 1 to not 2. 1 to
tangent. I'm
you are currently sitting. Okay, 1 over root 3, which is great, but it's only half credit. We rationalize, which gives us root 3 over 9, which is perfect. And square root of 9 is root 3 over 3. One more time, those 3 ratios, just like the other side I said, you're going to get those so often. Not probably this year, but enough next year, you're going to know those off the top of your head. We're not there yet. Okay. All right.